Okay, this is for advanced algebra, topic 9. This is section 6. I'm going to actually divide this into I'm going to divide this into two sections. One where we focus on using the quadratic formula to solve equations, and the other where we use the discriminant to determine the nature of the roots. So I'll divide it into two different videos. Treat it as two different topics, kind of, sort of. So what we have is I have here is the quadratic equation in standard form, and when we complete the square on this, then what we get is the quadratic formula. Okay, so we completed the square in the previous section. So what we do is we move the constant to the other side. We have ax squared plus bx equals c. And then the leading coefficient here for x squared has to be 1. So I'm going to factor out an a, which will leave me with x squared plus b over a x equals c. Okay? And then I'm going to take half the coefficient of the linear term, which is b over 2a, sorry, and I'm going to square it. And b over 2a squared is b squared over 4a squared. All right. So when I bring that out, it gets multiplied by this a. So when I multiply by this a cancels with one of these. And so what I'm adding is b squared over 4a. Okay. Now I factor this thing, and I get x plus b over 2a quantity squared. That a is still out front. Okay. And I'm going to go ahead and get a common denominator over here. So that's going to give me 4ac on the top over 4a plus b squared over 4a. And now I can add those together and have a times the quantity x plus b over 2a squared equals, little mistake here. When I moved this c over, I should have made it negative. Okay, sorry, I just moved it. So that's going to be negative. And when I add these together now, I'm actually going to switch that around. I'm going to write that's b squared minus 4ac all over 4a. Okay. And now I'm going to divide both sides by a. And so that's the same as multiplying by 1 over a. And so I get x plus b over 2a quantity squared equals b squared minus 4ac all over 4a squared. So now you might recognize that I need to take the square root of both sides. And so when I do that, I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. And as you recall, over our section of simplifying radicals, we said that we can separate this, and I can't simplify the top, but the square root of 4a squared is 2a. So, and I'm going to move that over at the same time. So I'm going to have minus b over 2a plus or minus the square root of b squared minus 4AC all over 2A. It looks like I have a common denominator, minus b plus or minus the square root of b squared minus 4AC all over 2A. That is the quadratic formula. And I can use that to solve any quadratic equation. Even if that quadratic equation factors, I could use this. Even if it's a binomial, it's the difference of two squares, I can use this. And even if it's just a regular standard old, problem, quadratic equation that doesn't have, doesn't factor, maybe isn't a binomial, whatever, and we get an irrational answer. Okay, that's where some of those answers come from. So the quadratic formula, there it is. The opposite of b plus or minus the square root of b squared minus 4AC all over 2A, and you're going to have to get to know that. And then when we go to solve these equations using the quadratic formula, we of course want to first have that in standard form. Okay, so I need to move this 4x to the other side, and not only do I need to move it to the other side, I need it to be in the middle. So this is x squared minus 4x minus 7. Now this particular quadratic, it's quite obvious it doesn't factor. 7 is prime. The only factors are 1 and 7. That's not going to make 4. So at first, I can go through here and I can say, well, a is 1 because that's the coefficient of the quadratic term. B is negative 4. And C is negative 7. So now when I go to solve this, the opposite of b is going to be 4 plus or minus b squared will be 16 minus 4 times a, which is 1, times c, which is negative 7, all over 2 times a, which is 1. And then we just simplify that thing. This is going to be 16 plus 28, which is 44. We get 4 plus or minus the square root of 44 all over 2. And then I think I can simplify 44. 2 times 22, and that's 2 times 11. So I can simplify that to 4 plus or minus 2 square root 11 all over 2. And now, because there's a 2 in every place, here, here, and here, all 3 places, I can reduce everything by 2 and get 2 plus or minus the square root of 11. And this method needs to become your new best friend. Okay? And that's our answer. That's where this parabola, this quadratic equation, intersects the x-axis. Those are the x-intercepts. Those are the zeros of the function. That's the solution, however you want to term that. Okay. So just like with the previous problem, I said the first thing we need to do is get it in standard form. And so on this particular equation, to do that, I'm going to move everything to the right side because that's where my x squared is. I have a partiality to my x being positive, my x squared term being positive. So everything is going to the right. So I'm going to have 0 equals x squared plus 4x minus 21. And then I just go into the quadratic formula. A equals 1, b equals 4, c equals negative 21. And so x equals the opposite of b, negative 4, plus or minus the square root of b squared, that's 16, minus 4 times a, which is 1, times c, which is negative 21, all over 2 times a, which is 1. Okay? And we start simplifying that. We get 16 plus 84 which is 100. So I have -4 plus or minus the square root of 100 over 21 over 21 over, and then I wrote it. That's even worse. Over 2. 2 times 1 is 2. And looky here, we got a perfect square. 100 is a perfect square. So this is the same as -4 plus or minus 10 over 2. And since I got a perfect square, I have to figure those out. And I just can't simplify the radical and let it be like we did on the previous equation. I'm going to take -4 plus 10 and divide it by 2. And I'm going to take -4 minus 10 and divide it by 2. So this gives me -4 plus 10 would be 6, divided by 2 would be 3. -4 minus 10 would be -14, divided by 2 would be -7. And I don't know if any of you recognized it, but you know, over here, when I set this equal to 0, I pretty quickly recognized that I could factor that thing. And it would factor to x plus 7, x minus 3, then I could set each factor equal to 0. But I think the reason that we put this example in here is to show you that the quadratic formula will work on anything, even a quadratic that factors. It works on anything. So, x squared minus 2x equals 24. So first things first, x squared minus 2x minus 24 equals 0. And here's the deal. You know, if you look at that and you know it's going to factor, then by all means use factoring. I pretty strongly feel that this one would factor, but since I'm trying to explain the quadratic formula, I'll go ahead and use a quadratic formula. Okay, so A is 1, B is -2, C is -24. So x equals opposite of B plus or minus square root of B squared minus 4 times A, which is 1, times C, which is -24, all over 2A. Let's see, 4 times 24 plus 4 is 100. So I get x equals 2 plus or minus 10. So yeah, it would have factored, right? When we get a perfect square there. And then I have to figure both of these out. So I'm going to take 2 plus 10 and 2 minus 10 and get 12 over 2 is 6, -8 over 2 is -4. And that's it. All right. So I don't know if you remember from free school, the 5 speckled frogs sitting on a speckled log, eating the most delicious worms. Yum yum. One jumped into the pool, ooh, where it was nice and cool. So here's this frog jumping into the pond. We know that its shape is going to be parabolic, right? It's going to reach its high point. This here's the equation that represents it. T seconds after it jumps off a rock. How many seconds is the frog in the air before it lands on the ground? So if we roughly look at a parabolic, curve like that, we want to know how many seconds it's in the air before it lands on the ground over here. So in other words, we want to find that x-intercept. We want to find that 0. And we have y equals -16t squared plus 10t plus 0.75. So basically, I can put that into the quadratic formula. I can do t equals the opposite of b, which would be -10, plus or minus b squared, which would be 100, minus 4 times negative 16 times 0.75 all over 2a, which would be negative 32. So I have negative 10 plus or minus 4 times 16 times 0.75 is 48. And because it's going to be a positive, that means in here I'm going to have 148 over negative 32. And it does simplify a little bit. Negative 10 plus or minus 2 square root 37 all over negative 32. And I'm going to divide everything by a negative 2. Old trick. So I'm going to get 5 plus or minus the square root of 37 all over 16. And, that doesn't mean a whole lot. So I would probably plug that into my calculator. Let me do that here. And one of the answers I get is negative 0.068. And the other answer I get is 0.135. So obviously this is where it took off from, kind of, sort of, loosely, and this is when it's going to land. So this is the answer we want, 0.135 seconds. And that's it for the quadratic formula. Like I said, I'm going to split this video up, and the other one will be about what we call the discriminant. So, put there.